The climate crisis is threatening dinner tables on the other side of the world at this very moment. Seeds that no longer sprout. Soil that yields less, no matter the effort. To the land where seeds no longer grow. The Department of Life Science at Handong Global University looked into the strength of the seed, and the Department of Mechanical Engineering sought tools to deliver that strength. Together with IRRI, the two departments at Handong have begun to combine their expertise to search for answers together.
The biggest issue we noticed in Tanzania's Mbeya plains was a serious imbalance in nutrition. There were several causes behind this, like climate change, economic struggle, and inefficient farming practice.
IRRI was one of the best places in the world for rice research. So we thought since they were already helping Tanzania, they invited our university to work together. Their labs and fields were perfect for testing our ideas, and they helped us try our methods in real conditions, similar to Tanzania.
As engineering students, we want to focus on areas where we could actually make a difference. That led us to work on improving agriculture tools, especially seeders. IRRI reports showed that using a manual seeder could increase planting efficiency by 50 to 20% compared to sowing by hand. That was a huge motivator for us.
Traditional rice cultivation relies on paddy fields, which can produce high yields but require large amounts of water. This is a critical disadvantage in developing countries where water is scarce, such as Tanzania. To address this, we sought to shift from paddy farming to upland farming, specifically direct-seeded rice, which uses much less water.
The machine needed to be height adjustable to fit different users, and it had to strike a balance heavy enough to stability, but not so heavy that it's hard to use.
For the material, our primary considerations, water retention and local availability. We considered options such as rice bran, turmeric powder, and baobab powder, but ultimately choose zeolite because it is a natural mineral with a porous structure and excellent water holding capacity.
During our field test, we ran into a couple of problems. Some seeds were getting crushed and the spacing between seeds wasn't consistent. Our goal was about 1 centimeter spacing. We realized the metal seed guide was damaging the seed, so we replaced it with softer materials like spongy or rubber to reduce the impact. We also adjustable to hole size on the roller to better control how the seeds were dropped. After making this change, the seeder's performance improved by about 20%, which was a big win.
I was able to confirm the importance of field activities by watching students adjust the seeder's roller immediately with feedback from IRRI experts and find solutions effectively even with limited resources.
At the IRRI site, many things were different from the lab, like weather, uneven soil, and limited tools. The students didn't complain. They made their own tools like a rake from straws and glue and worked together to solve the problem quickly.
We overcome this by using everyday materials like straws and coffee cup lids to increase experimental efficiency.
IRRI was impressed by how creative and practical our students and ideas were.
Collaborating with the mechanical engineering team was very helpful for improving the practicality and scalability of our technology. Discussions about the mechanically dispersing both seeds and zeolite addressed the limitation in efficiency we experienced in the field.
Our project wasn't just about helping or testing. It was about solving real problems using science. This showed me they were really learning how to think and work like scientists.
They were learning how to practice neighborhood love through technology.
The theories once learned at a desk met real questions in the unfamiliar soil of a distant land. Before asking what to study, they first asked why the research was necessary. By confronting challenges head-on and crafting solutions with their own hands, the students discovered a clear path through what once seemed impossible. The GRP program empowers them to find that path on their own.